Finding the right fire detection system for industrial facilities is not easy. False alarms, recurring maintenance issues, access issues for system testing, damage. Sound familiar? We have the solution. Listec is a unique addressable heat detection cable system designed specifically for harsh environments where humidity, dust, frost, fog, vibration, exhaust fumes and salt are all prevalent, and for areas that have access or maintenance issues after installation. This robust cable has heat sensors hermetically sealed inside it at predetermined intervals. Each one of these sensors measures temperature with great accuracy, and each sensor has its own individual address. The integrated sensors operate similar to a grade 1 rate of rise heat detector, monitoring for alarm temperatures between -40 to +85 degrees C, with a resolution of 0.1 degrees C. The distance between each heat sensor is freely selectable. You can choose between 1, 2, 3, 4 and 5 meter spacings. So, for example, if there's an area where you require condensed monitoring, you can select a heat sensor every 1 meter across the cable. And for areas that are not as critical, you can select a sensor every 5 meters. As you can see, the cable is very durable and extremely flexible. Watch how easy the cable is to strip. If we look inside the cable, we can see how the cable is constructed. The diameter of the cable is 15 millimeters. The outer cable jacket is a flame retardant sheath. Then we have an aluminium shield, which screens the cable from electromagnetic interference. The filling material is a thermal compound, which attracts heat. The heat sensor sits on top of a 2-core flat conductor. Sealing and fixing the cable is a very simple process. To seal the end of the cable, you apply one of these end caps. No series or end-of-line resistor network required. Simply heat shrink the end cap to complete termination. And for fixings, as you can see here, these metal safety clips hold the cable firmly in place, whilst being easy to detach should any adjustments be necessary. The flexibility of the system is one of its key benefits, and this clever connection box is key to that flexibility. If you wish to mix and match the sensor spacings between sections of the cable, for example a sensor every 1 meter in one room, then a sensor every 3 meters in another room, this can be achieved across the same length of cable by connecting one end of the cable into the box, and then coming out of the other end with your next run of cable in the next room. We also use these connection boxes to attach external sensors. External sensors are used to monitor the temperature of a particular apparatus or component, for example a bearing, a motor, a sump or any critical risk item. So rather than snake the sensor cable down, we can break into the cable using a connection box, and the external sensor is dropped down to monitor, say, a motor. The stainless steel casing can be bolted to the side of the motor, and inside this casing is a heat sensor, which again will have its own individual address. This is the brains of the system, the sensor control unit. This control unit measures the temperature of each connected sensor every 10 seconds, evaluates the data, and then sends the information to either your fire alarms control panel, whether it's analog addressable or conventional, host computers, or other transmission systems. This information is transmitted either via Modbus or relay modules, and with relay modules you can drive up to 64 outputs. The control unit is capable of reading data across 500 meters of cable, and to cover longer distances you can network multiple control units in a daisy chain. And that 500 meters can be a mixture of sensor cable and field wiring, for example fire cable. It does this in the form of 2 branches. 250 meters from branch A and 250 meters from branch B. The parameters here are that the control unit can measure up to 198 sensors in total, 99 sensors across branch A and 99 sensors across branch B. The control unit reads the temperatures of each sensor in 2 ways: fixed temperature and rate of rise over a 10-second cycle. The temperature alarm thresholds can be individually selected at each sensor point, For example, the fixed alarm temperature can be set at 50 degrees C across one group of sensors and say 64.3 degrees C across a different group of sensors. The same applies to the rate of rise or differential alarm settings. In this section, you can set the rate of rise alarm to activate at 2.8 degrees C. Then in a different section of the cable, you may wish to apply a more sensitive setting of, say, 1.9 degrees C. Should an alarm threshold be exceeded, an alarm output is activated. In short, any area can be soak tested over a designated time period. The client can then assess the findings and freely adjust the temperature alarm settings to tailor the system to suit site conditions. Pre-alarms are also available. You can have a pre-alarm set at 90% of the fixed temperature alarm threshold and 50% of the rate of rise alarm threshold. Both of these pre-alarm settings are adjustable to suit site conditions. Let's take a look at the front panel of the control unit and see what these lights indicate. Fire on branch A, fire on branch B, fault, which could indicate an open or short circuit fault in the cable, power, measuring cycle. This amber LED indicator pulses every 10 seconds. This is the control unit taking a reading of each sensor across the entire length of the cable. Data transfer, reset or acknowledge. If required, this can be disconnected on the unit, so the reset is carried out remotely, for example on the fire alarm panel. Also available is a master-slave, the list controller. You can also add a touchscreen visualization of the entire system. It can assess and program all of the control units. In essence, the control room of the system. Here is an example of a typical installation within a cable raceway. The sensor control unit is located near to the protected area. Field wiring is connected from the control unit to the connection box on the roof of a cable raceway. The sensor cable is then wired from the connection box along the roof of the tunnel to monitor temperatures across the entire length of the cable raceway. An end cap completes termination. Take a look at this graph to see how the system measures fixed temperatures across the length of the cable. If you look at the left-hand side, these are the temperatures in degrees Celsius, and along the bottom of the graph is time. Each one of these numbers represents a 10-second cycle. The alarm threshold in this instance has been set at 50 degrees C. So we can see here the temperature rising, and every 10 seconds the sensor control unit is checking the temperature of each sensor. You are able, if you wish, to set a pre-alarm. So, for example, you could set the pre-alarm at 90% of the fixed alarm threshold, in this instance 45 degrees C, and then as the temperature rises to the absolute alarm threshold, 50 degrees C, an alarm output is generated. This graph shows how the sensor control unit tracks the temperature of each connected sensor every 10 seconds. Now remember, the control unit is looking at both fixed temperature values and a rate of rise over a 10-second cycle. The green line represents the ambient or actual temperature. The sensor control unit checks the temperature of each sensor every 10 seconds. And this yellow line represents the tracking of those sensors and their confirmed temperatures. We call this yellow line the reference value. There are no abnormal temperature rises occurring in this graph, so as we can see, the reference value is running in parallel with the ambient temperatures of the connected sensors. Now, let's see how the system reacts when there's an abnormal rise in temperature. Again, the green line represents the actual temperature of each sensor, and the yellow line is the sensor control unit's reference value. Every 10 seconds, the reference value is monitoring the actual temperatures and is calculating the difference between what those temperatures are reading now to what they were reading 10 seconds previously. It's looking for a rate of rise in the temperatures over this period, and in this example, the rate of rise alarm threshold has been set at 3.4 degrees C. Now we can see that the green line representing the actual temperature has suddenly increased, and the sensor control unit's reference value, the yellow line, is tracking this. During each 10-second cycle, the rate of rise is increasing, which will eventually reach the differential alarm threshold, in this case 3.4 degrees C. So the sensor control unit generates the alarm and will let you know precisely at which sensor point this has occurred. The system operates precisely the same way in a freezer or cold storage area. The only difference is the temperature alarm settings chosen by the user. Here, the actual temperature alarm has been set at -25 degrees C. And again, you can choose to have a pre-alarm signal. So as you can see, the system also works for negative temperature monitoring. This tech's alarm generation response times comply with British Standard EN 54 Part 5. The system is ATEX certified to operate in hazardous areas. Simple, clever, durable, flexible, practical, and best of all, open protocol. If you want to future-proof your fire protection, take a closer look at Listec.
In today's regulated business environment, it's essential that organisations of all sizes can demonstrate their ability to manage risk. But assessing risk can be a lengthy and complicated process, and demonstrating compliance requires a clear and accurate picture of an organisation's entire estate. RiskWarden delivers compliant, risk-managed environments. Our easy-to-use cloud-based platform streamlines the assessment of risk. It creates unique risk profiles for your organisation, weighted to ensure you focus on the most critical needs. RiskWarden allows you to manage risks by highlighting improvements and allocating and tracking tasks. It provides clear evidence of compliance, demonstrating that your organisation can meet its obligations. Powerful reports and dashboards present all your risk-related data in one place, while a log captures all events and actions for audit purposes. Our solution demonstrates compliance with workplace regulations. It is quick and easy to set up with access from any internet-ready device from anywhere. RiskWarden provides SSL encryption between a browser and the system. It has been penetration tested by third parties and is hosted on secure servers located in the UK. It's a simple process to add users, risk assessments, or risk types, and it's affordable on an easy-to-manage subscription basis, and in most cases there are no setup fees. RiskWarden is accessed via an intuitive web-based interface, guiding assessors through the entire risk assessment process, providing time-saving presets for the many types of risks. Images can be captured and placed directly into reports, while templates for specific building types ensure consistency. RiskWarden is unique. It's designed around the needs of risk managers and those who assess risk. Its ease of use, flexibility and cost effectiveness are best in class. Most importantly, Risk Warden will help you achieve a compliant, risk-managed environment. For more information about how Risk Warden makes risk compliance simple, please visit our website.